So guys, here we have a problem, how to use complex analysis to solve integration problem. So we are going to solve a sample integration. I think most of you have solved this kind of integrations, but I will tell you the procedure, and after that we'll be able to do it by yourself. So let's look at this integration. The integration over 0 to 2 pi d theta by 13 minus 5 sin theta. Now with this kind of integration you have done in class 12, but you have done it in a conventional method. Now the question is, how can you use your complex analysis technique to simply solve this kind of integration? So let's look at this. The given integration is 0 to 2 pi d theta by 13 minus 5 sin theta, d theta by 13 minus 5 sin theta. This is given. Okay, so to solve this kind of integration, what we need to do, we have to just convert it into complex integration. For that we have to select a particular contour. So let's say this is the contour we are taking in an anti-clockwise sense, and it has unit radius, and we can mathematically represent this circle as mod of z is equals to 1. Okay, so if the radius is 1 unit, we can let z is equals to r e to the power I theta. That is a general formula, but the radius is 1 unit, so you are writing z equals to e to the power I theta. So your dz will produce I e to the power I theta d theta. Now e to the power I theta is z, so we can write it I z into d theta. From here we can write d theta is equals to dz upon I z. So this value will be utilized in converting this normal integration into some complex integration. Furthermore, we are given sin theta. What is sin theta? Sin theta is given by e to the power I theta minus e to the power minus I theta divided by twice I. So this is the form of sin theta. Now if you utilize the value of z equals to e to the power I theta, so z inverse will be e to the power minus I theta. Okay, so this is z minus z inverse or 1 by z times this 1 upon 2i. So we are going to just replace these values into this integration to make it a complex integration. Then we can utilize the complex integration formula. We can utilize the Cauchy's residue theorem to evaluate the integration. That's it. So this 0 to 2 pi, this limit is being converted into a contour like this contour C, which you have considered here. Okay, now as you have considered this contour, this d theta cannot sit there. Instead of d theta we have to write dz by iz, and this sin theta cannot be there. Instead of sin theta you have to write this thing. So let's write. So our complex integration takes this form, dz by iz divided by 13 minus 5 sin theta. So 5 by 2i into z minus 1 by z. So if you somehow evaluate this integration, that will be similar, same to that integration. So in this way you can easily utilize the complex integration technique to get the integration value. Now simply simplify this. So what will you get? This 2i, this I get cancelled, so 2 into dz divided by 26 iz minus 5 z square plus 5, and this iz, this 1 by z is also coming, that is why you are getting 2iz. Okay, na? Just keep it like this, will not jump any step. Okay, so this is dz by iz. So we have taken the LCM 2iz and we have got this, and what will be its value? So this will be okay, sorry, I forgot the integration sign. Integration contour is C, so this will be dz by, if you want to take this z square term first, so we have to take a minus sign here. So we have taken minus 5 z square 26 iz, so minus 26 iz minus 5, and this 2i z and I, this I gets cancelled, so 2z 2dz into this. Got it? So this will be equals to minus integration 2dz by 5z square minus 26iz minus 5. Now we have got this integration in the conventional form. Now you know, to evaluate the integral we need to set up the denominator to 0 to find the poles. So we are setting the denominator to 0. Now if you set the denominator equals to 0, you can get two values of that, right? So quadratic equation, so it is involving complexes, so you can utilize the Sridharacharya formula. So this will give you 26i plus minus root over b square minus 4ac. So this will give you minus 576 if you calculate, divided by 2i, 2 into 5, so 10, and this will produce 26i plus minus 24i by 10, which is equals to, so 26 plus 24i, so 5i, one value will be 5i and another value will be I by 5. So these two values. So what is the position of 5i and I by 5? So you can see this is our contour and this is our y-axis, means I-axis actually. Okay, this is the x-axis. So it is like 5i is outside the contour. Okay, this is I, 2i, 3i, 4i, 5i. So 5i is outside the contour, but I by 5 will be somewhere like this. This is I by 5. So only I by 5 is lying inside the contour. So out of these two poles, what we can say that only z is equals to I by 5 is lying inside the contour. And you know, for this type of integration we have to consider only those poles which are lying inside the contour, and at that pole we have to find out the value of the residue. So let's calculate the residue at z is equals to I upon 5. Okay, so we can utilize our formula limit z tends to I by 5, z minus I by 5 into f of z. F of z is z minus 5i into 5z minus I. Okay, from this we can write this like this. Now what kind of value will it produce? Z minus I by 5. So if you take 5 common, so 1 by 5 will come here. So this will give you z minus I by 5. So z minus I by 5 is cancelling. So what you have, 1 by z minus 5i. So z equals to I by 5 minus 5i. I by 5 minus 5i. You have put the value of the limit, and if you evaluate this, what you gonna get? You're gonna get I upon 24. So you got the residue value. So what is the integral value now? Okay, my page is running out. Anyway, जो भी है हम लोग अभी कैलकुलेट कर सकते हैं. So therefore 0 to 2 pi. We are just now writing the parent integration 13 minus 5 sin theta, because we have already converted it into complex integration and we have found the residue. So 2 pi I into sum of residue. This is the formula. Okay, na? 2 pi I into sum of residue I by 24, and furthermore you have this minus 2 here, so which you have to consider also. So minus 2. So if you multiply these things, then what are you getting? This I and I square is minus 1 minus minus plus. So 4 pi by 24, so pi by 6. And if you closely look at the options, it is matching with option D. So option D is the correct option for this question. So I hope you have fully understood this integration. Just look, the process is simple, although it is a little bit lengthy, but the overall process is very simple and satisfying. So I hope you have understood the complete procedure. If you have any question, you can just let me know in the comment section. I'll definitely try to answer them all. And guys, you can just follow me on Unacademy Plus. You can visit my profile by going to this URL unacademy.com/@physics, and you will get all my detailed courses like mathematical physics, classical, electromagnetic, quantum, plus statistical, atomic, molecular, condensed, etc. There are a lot of benefits of taking an Academy Plus subscription. You get daily live classes, assignments, and many other things. You can just pause and read all of them. I have written many points about the benefits of Plus subscription. And thus, guys, price rise up to 20% is coming soon, and it will be effective by 31st of May. So if you are willing to take the Plus subscription, take it before 31st May. Otherwise, you have to pay some extra money, which I don't want, and you also don't want. So currently these plans are available 3 months, 6 months, 12 months, and 24 months. Whatever plans you buy, you just apply this referral code PHYSICSHUB PHYSICSHUB, and Unacademy will give you the maximum benefits. So if you have any query regarding anything, you can let me know in the comment section. And this is all for this video. Thank you very much. See you in the next video. Bye bye.